I will present this paper, which is a joint paper, and I wrote it with Mr. Isaac, Mrs. Silveira, and Professor Fernando Perobelli. So it's the Brexit game. We are trying to model a firm's locational decision in an environment surrounded by uncertainty. That's why we choose to discuss this Brexit event. And so this was a research that I developed when I was at the Federal University of Juiz de Fora, and we developed this research together with this research group called LATS, which provide a high quality research on regional analysis and urban economics. So it belongs to the Department of Economics at the Federal University of Juiz de Fora. So a brief outline that I will discuss today. I will start with the motivation, then I will discuss a bit of the methodological aspects. I will talk about the strategic elements evaluated in the location decision. I will introduce some features of the input-output model. Then I will start discussing about the motivations behind the game model. And then I'll introduce some key concepts about evolutionary game theory. And I will also introduce the Payoff Matrix, show some intuitions behind the Replicator Dynamics, which is based in a system of ordinary differential equations. And then I will combine this approach with the agent-based simulation algorithms. Then I will move to the result sections, in which we have different scenarios to discuss whether firms will decide to locate, considering different European Union countries. And then I will finally offer a brief conclusion and also point to future research. So, well, this paper aims to analyze the strategic behavior of firms regarding their location decision, as I told before, and we are just evaluating Brexit as a case study. This is a very flexible model. It's a general model. We can discuss many situations in which we have this uncertainty surrounding firms' locational decision. So we are just trying to explain how the agglomerative effects may occur in an environment surrounded by uncertainty. That's why we chose Brexit. And we are aware that this discussion belongs to many fields in the economic literature, and such as industrial organization topics and regional economics, and also in international economics. But despite of that, we have few studies about spatial competition lying this interface of evolutionary game theory, agent-based models, and regional science. And that's what we are trying to combine here, to put these three different approaches together in the same framework. So we are proposing a model based on an input-output structure within which an evolutionary game will be played. And by doing so, we just separate the European Union in different strategic regions. We split it between United Kingdom and the rest of the European Union. And here we are evaluating two different sectors with different features. So one sector is related to crop and animal production, hunting, and related services activities. We can understand this sector as agricultural sector. And the other side, we also evaluate the financial service activities. And so actually what is going behind this game is that the payoff structure of the game will decide firms' locational decision. And so we are considering a set of variables, strategic variables, that will guide firms to their optimal locational decision. And if their goal is to maximize market share, they may assign greater weights to the variables, market potential, and productive integration. On the other hand, if firms are seeking to minimize costs, they might attribute greater weight to labor costs and to displacement costs. So we are just trying to find a way to capture some essential variables, strategic variables that might help firms in deciding whether they should be located at. And to increase the realism, to connect our approach to this real world situations, we developed this stochastic learning rule through the spatial agent-based simulation model. The ABS approach is, we believe that it's a good approach in order to understand the economic situations that involving dynamically interact decisions and where firms can learn with their own choices over time. And that's what we are trying to model. We assume that firms are bounded rational, and they learn. They can learn with their own stakes, and they can learn with the strategies from the other firms that are closer to them. So both the evolutionary game theory and the agent-based simulation models may overcome some drawbacks of the existing literature about firms' location decision, especially in situations in which the economic environment becomes a complex system, such as the Brexit event. And here, as I told, we are following this approach in which firms are assumed to be bounded rational, and then firms' strategic behavior goes beyond the payoff utility maximization. So we are trying to give a step forward in this traditional analysis in which, the classic game theory, for instance, always assumed that firms are profit maximizers, and sometimes it's a bit unclear on how to introduce learning abilities in their decision making. So that's what we are trying to use here. And by doing so, we are considering that the firm's decision-making is rule-guided. It relies essentially on institutional frameworks and organizational skills. And there are many evidences in the literature that routine behavioral firms, together with their learning abilities, are related to agglomeration and regional growth differences. And by some corporate culture, we consider that firms can learn from their own mistakes through the trial and error dynamics, and also by mimicking their rivals' behavior strategy. And in our case here, we consider that competition is acting like a natural selection device, where intelligent firms, I mean the ones able to adapt their routine to the environment in which they compete, will spread in the long term. Then firms' persistent growth over time is also correlated with their ability to adapt to the economic system that they belong. And then, in order to measure these consequences of Brexit to the economic activity, we consider the projections made from the regional economic analysis, in which we use this input-output database that will be the basis of our evolutionary game. And now I will just say some words about this key concept, which is the evolutionary stable strategy. It's a concept closer to the Nash equilibrium. It does represent the optimal strategy location decision in the long term. So we are in a situation, we are in an environment where firms have no incentive to abandon their locational strategies. So they are in an evolutionary equilibrium. And following this framework, we simulate a game in a spatial structure to capture some of the behavioral aspects of firms' decision-making, as well as the clustering dynamics according to the occurrence of Brexit. And so I will just briefly explain about the strategic elements. So to develop the methodology, we consider a game involving two types of firms. And we have one population of firms that is situated in the rest of the European Union and are assessing the possibility of migrating to the UK. So I will call them type A firms. And on the other hand, we have these type B firms, which is a population of firms that is situated in the UK and are evaluating the possibility to migrate to one of the European Union countries. Okay, so we have two populations of firms. And that's how we will start modeling our game. And as I told before, the payoff structure of the game will guide them through this equilibrium. And the payoffs are based on the global regional input-output matrix. It's made available by this database, this world input-output database for the year of 2014, with sectors opening of 33 countries and 56 sectors of economic activity. And so countries here were aggregated so that the interregional input-output matrix containing the same 56 sectors for the three following regions. So we have the United Kingdom that also have the Great Britain, and we have the rest of the European Union and the rest of the world. So that's how we divided our database in order to get some information and then to build our payoff structure of the game. Okay, so I will explain a bit about this input-output model, which is crucial for our analysis. And first we have this representation through equations 1, 2, and 3. And the first two equations just represents the equilibrium conditions for the domestic and imported goods production. And the equation 3 represents the equilibrium condition that will add a constraint in the input-output coefficients. So here I'm just trying to understand what will going on when we do this exercise of extracting the UK from the European Union countries. And so we are evaluating 4 different set of variables. I will start describing this market potential. And so the market potential for the non-Brexit cases will be expressed as the sum of the technical production coefficients for all sectors of the countries of the European Union in equation 3. And then considering Brexit, the market potential will be measured by the hypothetical extraction of the UK from the European Union. And then once we did that, now UK's market potential is given by the sum of its all coefficient production, it's given by the sum of its all technical production coefficients. And the market potential of the rest of the European Union countries will correspond to the sum of the technical coefficients for all sectors of the countries of the European Union. And another key variable in our analysis is the productive integration. And to measure that degree of productive integration, we use the value-added indicator of gross exports as follows. And the intuition behind this ratio is that the higher the coefficient, the lower the degree of productive integration of the country in the sector that we are analyzing. Remember that we are trying to model firms' behavior in 2 different sectors. We are considering the agricultural sector and the financial sector. So we believe that firms from these sectors will be guided by different set of strategic variables. So that's why we are considering, these 4 variables. And we also have variables associated with the costs. And so we have labor costs, and the cost of labor force should reflect the costs absorbed by firms, taking into account skilled and unskilled labor force. And we are also comparing these for the same amount of production in each sector and in each country. So the cost of the high and low skilled labor can be obtained by the product between the participation of each type of labor in the total remunerations and the gross value of the production of each sector and for each country. And we also have the displacement costs associated with the allocational decision. And it's also associated with differences in the share of high skilled labor and low skilled labor between different countries for the same quantity produced. So we have these equations 5 and 6. Actually, equation 5 is giving us the displacement cost if Brexit occurs with probability S. And as we might have another scenario in which the Brexit do not occur, we have to consider this displacement cost as a function associated, with the probability that Brexit will not occur. So that's why we have these 2 different equations, but they are measuring the same effect, which is the displacement cost. So just let me drink a cup of water here. So now I will discuss a bit about this game model. I will start with the evolutionary Brexit game model and some key concepts about evolutionary games. So departing from an initial condition, a unique stable steady state will be reached. And by doing so, we know how firms choose between multiple locational strategies. And we believe that this is how we can study the robustness of firm strategic behavior. So we assume that they are bounded rational firms, and they are not aware of all the strategic variables at the beginning of the game. They don't know exactly how much they will win in specific situations, but they know how to learn. They can observe the other firms' behavior, and then they will updating their strategies over time, and then they will reach this equilibrium. So that's how we set our model here. And so we assume bounded rationality, we assume a large population of firms, and we assume also that firms can learn. And in every period, a firm will be randomly matched with another firm, and they will play a simple two-player game. And each firm is randomly assigned a location or strategy. At the beginning of the game, we can choose between one of the European Union countries or the United Kingdom at time step 0. And as I told before, firms will update over time their strategy. And it's done by the systematic interaction with other firms. Thus, one firm can mimic other firms' strategy. And so about the payoff matrix of the game, we consider that firms are evaluating the possibility of relocation according to whether Brexit is likely to happen or not. And so in this payoff matrix 7, let the role player be a representative type A firm, and the column player be one representative type B firm. So the payoff matrix is given by this payoff matrix number 7, in which we have all the possible combinations of payoffs here. And just to show you a better intuition about this, so we have this. Let's suppose that we are evaluating these strategies where both firms are deciding to locate in the UK. So the one firm will get the payoff Pi A1, and the other firm will get the payoff Pi B1. So here's how we are computing these payoffs. PA1, remember that we have a population of firms that are already located in the UK, and another population of firms that are located in one of the European Union countries. And so the type A firms is the ones that are located in one of the European Union countries. So it will have the following payoff. It will split the market potential with the other firm because they are sharing the same geographical region. And they will also split the productive integration for the same reason as before. And then here we are just computing the costs associated with both the skilled and the unskilled labor force. And here we see that a firm that is initially located in one of the European Union countries will have to incur in displacement costs. So both when the Brexit is more likely to happen or not. That's why we are just capturing here different values from that we world input-output database. And once we do not consider that Brexit will happen, we have different values extracted from this matrix. And that's why we have to consider both scenarios here. And here we have the coefficients associated with these key variables. And also we say that firms can attribute weights. Okay, and here by terms type B firm, the one that is originally located in the UK, it has a payoff very similar to the other one because they are choosing to be located in the same region. But as it is already located in the UK, it will not incur in this displacement cost, as you can see here. It will have only to consider 3 key variables in its locational decision because it's already located in the UK. So that's how we built this payoff structure. And here in Payoff Matrix 8, we are just doing a normalization that will help us with the discussion about the replicator dynamics, which is guided by a very general ordinary differential equation systems. So I'm just substituting rows and columns for specific values. So I have zeros here that will make my calculation way more easy, okay? So I will talk about the replicator dynamics right now. And as I told before, this is just a system of ordinary differential equations. And the intuition behind that is that it provides us some information about the growth rate of the proportion of firms that are adopting the first peer strategy, which is UK, within each population. So you can see here that FA dot is influenced by the proportion of firms in the rival population that is deciding to be located in the UK. So this system of equations will guide the deterministic dynamics of the game. So it's a very popular way to get some solutions in evolutionary game theory. And we have two conditions to evaluate the stability of a specific strategy. The first one is that FA dot and FB dot must be equal to 0, which means that there is no updating strategies going on in this environment. So it's a necessary condition for the stationarity of equations 9 and 10. And the second condition that we need here for this is that the stationary points must be asymptotically stable. And for reaching this result, we need that the eigenvalues of the Jacobian matrix, the matrix of the partial derivatives, evaluated at the points that hold the conditions FA dot equals 0 and FB dot equals 0, it must have negative real parts. So once we have these two conditions here, we can say that firms will be playing an evolutionary stable strategy, okay? So this is just one of the steps that we did. And the second one is to discuss a bit about this agent-based model. And that's how we introduced this into our analysis. I will try to spend a bit more time on this in this figure right now, in order to explain to you how I put it together with the agent-based, together with the evolutionary game theory. So I have that payoff matrix that I introduced to you, and now we are complementing this evolutionary game theory framework with the stochastic learning rule that is guided by this equation number 11. And as I introduced it before, we are considering two populations of firms. And here I also assume that firms from one population will only compete with firms from the rival population. So they do not compete with their peers. Actually, they will learn with their peers. I mean, from the firms that belongs to the same population. And so at the beginning of the game, we have, I'm just illustrating this here as a population of firms that is spatially distributed. And so we will allocate in each cell of this regular lattice structure a firm with a given strategy. So let's say that at the beginning, I choose at random this cell A33, which is a firm that is evaluating the possibility to be located in, it is already located as we are here in the population A. So this is a population of firms that is situated in the European Union countries and are evaluating to migrate to the UK. So let's say that this firm here is evaluating this possibility to migrate to the UK. And so it will compete with a specific neighbors from the rival population. So we have here, we set this local neighborhood as the players that are in the same geographical position as A33, but in the rival population. So we have B33, B23, B43, B34, and B32. So it's a very flexible algorithm. And we just set this as the von Neumann neighborhood, okay? And so A33 will play against these local neighborhoods, and we will compute its average payoff, which is given by this VI here. And then he will compare its payoff with A34 that will compete with B34, B44, B24, B35, and B33. So we also take the average payoff earned by A34, and we see the difference. Every time that A34 performs better than A33, A33 can mimic A34 behavior with this probability. And here we are just doing this normalization procedure in order to assure that W will be between 0 and 1. And once we have this probability, we will call a random number generator between this interval of 0 and 1 and following a uniform distribution. And we will compare W with this random number generator. So every time that W is greater than this random number generator, we will consider that 833 will update its strategy and will play the same strategy as 834. Otherwise, when 833 performs better than 834, it will keep his originally strategy and will not mimic 834 strategic location decision. Okay, so we can discuss a bit more about this in the Q&A sections, but this is the part of the paper that I really enjoy to talk about. So, and once we are just showing these approaches, I will move from the result sections. And so here, just to introduce you, we are considering different scenarios. We have this homogeneous scenario in which we are attributing the same probability for the Brexit occurrence and for the non-Brexit. Okay, and we are assuming that firms are kind of naive firms because they are assuming equal weights for all strategic variables considered in our analysis. And then in scenario 2 and scenario 3, we are trying to provide some more intuitions when firms consider that Brexit is more likely to happen. And actually, in scenario 2, they are evaluating, they are attributing more weight to the strategic variables associated with the market share maximization problem. And here in scenario 3, they are attributing more weights to the cost minimization. Here we have the weights associated with the labor force costs and the displacement costs. And here we have the weights associated with the market potential and the productive integration. So that's how we are considering these scenarios for both sectors 1 and 41. And here at the beginning of our analysis, I would call this homogeneous scenario as the naive scenario. And for both sectors 1 and sector 41, we have the same dynamics. And again, for those who are familiar with the system of ordinary differential equations, this is just a vector field, a phase diagram, in which we can see the evolution of the strategic behavior of the firms. So let's say that in a given initial condition here inside this square, let me assume that both firms are closer to this point here, where both are deciding to be located at the UK. So we see from the vector field that it's not evolutionary stable strategy. It's not an equilibrium point because the vectors are going through another direction. So this is actually a saddle point. And we see that the only equilibrium for both sector 1 and sector 41, we can see that the dynamics of the phase diagrams are pretty much the same, is that we have one equilibrium in which type A firms and type B firms, they will switch their location strategy. And so the homogeneous scenario features a unique balance for both scenarios for both sectors 1 and sector 41, which will be given by UK and EU. So we observed that firms that were initially operating in the European Union will update its location decision to the UK. On the other hand, the firms already established in the UK, observing this movement, will do the opposite movement. That is, they will start to migrate to one of the European Union countries. And the economic intuition of this equilibrium is that firms have some benefits when incurring at the displacement costs, since it relocates to an unsaturated market. But as I told you before, this is just a kind of a naive scenario. And to increase the realism, I mean, to answer the questions to where firms will decide to locate, we need to disaggregate these European Union regions in more countries. So as you know, we are just considering strategies as the countries. So we see here from this homogeneous scenario that considering a low level of spatial division, in addition to not providing greater relevance to any of the factors considered, there is a need to better evaluate the trade-off between the advantages of agglomeration that is given by our potential market and productive integration parameters, and compare them with the production costs, which is given by the labor force costs and the displacement cost. So in addition, another relevant issue is to know more precisely in which of the European Union countries firms will decide to locate. Then that's why we use this ABS model, agent-based approach model, to better evaluate the dynamic equilibrium of the spatial competition among firms. So here, I'm just providing a match between the replicator dynamics approach with the agent-based model approach. So we got the same result, even using the replicator dynamics and the agent-based model. So we observed a good level of agreement between the techniques. But from here, we can see that we have an initial frequency here that is given also by that World Input-Output database from the year of 2014, and it does reflect the share of firms that were located in the UK and the share of firms that were located in one of the European Union countries. So we put them to play the game based on this payoff structure and considering that W probability that guides the agent-based model algorithm. And what we see is that we achieve the same results. So firms that initially belong to the UK will migrate to one of the European Union countries, and the firms that originally belong to one of the European Union countries will move to the UK. So, and here we can see that some clustering of the firms. So firms that are behaving in the same way, they are staying closer to each other. And then we achieve finally the equilibrium in which we have this situation where one population of firms will be at the UK and the other population of firms will be in one of the European Union countries. And once we start to attribute more weight to the variables associated with the market share and to the productive integration, now we can disaggregate our payoff structure. I mean, we can separate from the European Union another countries. And how we did that? We just look at this, from this World Input-Output database, we can list the countries that has higher values for these parameters. So that's why we put it together with the UK and the EU strategy. So here we see that when firms are giving more emphasis to the market potential and to product integration, they might decide to move to Luxembourg or to Portugal in sector one, the sector associated with the agricultural services. And here we are just computing the payoffs of the games based on these assumptions. And what we see is that at the beginning, we are just considering the initial proportion. We are just considering the initial proportion of firms. And then what we see in the equilibrium is that one population of firms, type A population of firms, the firms that were originally situated in one of the European Union countries will decide to go to Portugal, and the firms that were initially located in the UK will decide to move to Luxembourg. It's for sector one. And for sector 41, we are trying to model the location decision in the financial sector. And what we see is that now we have UK, you have European Union, and we also have France and Finland as a final destination for firms location. So what we see here is that one population of firm will decide to move to, here it's France, and the other population of firms will decide to move to Finland, okay? And here in the scenario 3, we are just giving more emphasis to this cost minimization. And when we do that, we look together with this input-output database that we use it, and then we can offer new strategies. So together with the UK and the EU strategy, we have this Luxembourg, we have Portugal, we have France, and we have Netherlands. So for sector one, the agricultural sector, when we increase this possibilities of locational decision, we see that firms will decide to split the same region. I mean, they will decide to be located in France, okay? And for sector 41, we do the same procedure, but as we are in the financial sector and with the information that we got from this world input-output database, we see that firms might choose between all these strategies here. So we have Germany, we have Finland, and yeah, we have Austria. And here we see that firms will decide to move to split the market region in Germany, okay? So that's the result for the scenario 3. And some brief conclusions. Brexit may modify the distribution of the relevant geographic markets on the European continent. And if firms are given more emphasis to the agglomerative advantages associated with displacement costs are irrelevant. So firms will see greater benefits when moving from the host country. And when firms, on the other hand, are given more emphasis to cost minimization, they will kind of counterpoint these factors with the relevance of productive integration and market potential when they are making their decision about where to be located. So firms can see greater benefits in splitting the same market. And in sectors highly dependent on natural resources and traditionally benefited by fiscal subsidies, Brexit might lead firms to search for unsaturated markets. And here I just provide some ideas for future research. And I was trying to incorporate a bit of Russia in this discussion. And so I think that it might be useful to broaden this research through this path. So we can, let's say that we have this model that it will be very general and flexible. And so our agent-based model would allow, for instance, to incorporate Russia as one of the strategic locations to be chosen by the firms. And thus, it would be possible to discuss some international trade policies, such as trade barriers or free trade areas, which might provide insights into how these measures would impact firms' locational decision in these regions. And we also could focus the discussion on firms' locational decision by considering only the strategic interactions between Russia and its borders with the European Union member states, which is Estonia, Finland, Latvia, Lithuania, and Poland. So that's what I had to present here today, and thanks for having me.